am Anil Kumar, sharing with you some important questions for a test on relative maximum and minimum. Most of the questions relate with analysis of first derivative. You can find increasing, decreasing interval and local extrema with this analysis. In case you want to learn from me, you can always send an email on the address given. Let us now enjoy the journey of success and get ready for the test. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, I am going to discuss with you a test paper which is based on increasing and decreasing interval. Extremely important topic for calculus. We'll analyze the first derivative to find increasing and decreasing interval. We'll use the table of values, the interval table, to also find local maximum and minimum points, which are also referred to as relative maxima or minima or relative extrema. This is a very important technique used for curve sketching. In case you want to learn from me, feel free to write an email on the address given. The questions are kind of tricky. I have not taken very simple questions to be true. Normally, a test paper will give you 50% as kind of very simple questions, and then we have some thinking and application questions with knowledge based. So I begin with knowledge based questions which are slightly more tricky than you normally see. That should help you to get more than 80% marks. In case you can solve the last 4 or 5 questions, you are assured more than 90% marks in any test paper on this topic. So let's try to understand these concepts. Question number 1 and 2. They basically relate to write decreasing interval for function from the graph, from the given graph. So we're given the graph, we have to write decreasing interval for function f of x. Question 1, graph of f of x is given below. And question 2 is graph of f prime x. This is not f of x. Derivative graph is given, right? So the first one is the graph of the function. So this is graph of the function. Straightforward solution. However, this is graph of derivative. And from that you have to find the decreasing interval, right? So I hope it is clear now. Question number 3 and 4 is kind of similar. However, this time you have to figure out the increasing interval of the function, but from the equations. So for each equation, you can find the first derivative, analyze the first derivative, and get your solution, correct? Question number 5. For what value of k will this function have a local maximum at x equals to minus 2? It's a reverse calculation question. We have already given you the local maximum exists, and that too at x equals to minus 2, but you find the function. Interesting and a very useful question from test point of view. Question number 6. This time we are given a polynomial, simple function. Define critical points of the graph of the function, find critical points, analyze using table, and then answer the following questions. Now this is a standard method. Basically, it's a knowledge-based question which kind of reviews all the concept. Determine the interval where the function is increasing or decreasing. Find local maximum and local minimum, right? Straightforward, more or less. Question number 7. Show that f of x equals to ax over bx plus c, where a, b, c are non-zero real numbers will not have any local maximum or minimum. You get the idea. Very interesting question. It comes under communication and thinking skills, right? So this is under communication thinking. So you have to basically show that the derivative is not equal to 0, right? So then there won't be any local maximum or minimum. Question 8. We are given a function and you need to find the domain, x-intercept, y-intercept, interval of increase and decrease, relative maximum, minimum points on this particular function. This is again a similar function, gives you knowledge based practice. Question 9, again a practice question. So these three have been put there so that you get used to finding derivatives for rational functions. Apply the quotient rule, right? So basically, apply the quotient rule and then test for the derivative. So that practice you'll get with these two questions. And now we have tips. We call them thinking and application questions, right? So these are very important application questions which you need to figure out if you really want more than 90% marks. The base of a rectangle lies along the x-axis and the upper two vertices are on the curve defined by y equals to k square minus x square, where k is constant. Determine the dimensions of the rectangle with maximum area. So you have to maximize the area, right? Very good question, seen in past test papers. Question 11. We are given a function, but this time 3x to the power 4 plus ax cubed plus bx squared plus cx plus d. Equation is of a polynomial where the coefficients are missing. Now the information is find the constants a, b, c and d if graph has critical points at -2, -73 and 0, -9. So we're given you two critical points. You should be in a position to get the function from here. Part B is to find relative extrema for the above function. So once you do part A, B should not be difficult. So I hope that is interesting, right? Okay, let's see question number 12, which is again an application question. An open top square base storage bin has surface area of 108 meters square. Find the dimensions of the bin to have the maximum volume. From the equation, relate the base with height and then solve. Question 13. F of x equals to, f of x is equal to, let me rewrite this, x squared times cube root of 6x squared minus 7. Now, whenever the radicals are involved, it becomes slightly more tricky to analyze the first derivative or the second derivative. That's why this question is here. I hope this set gives you good practice and also exposes you to the variety of questions expected in the test on this particular unit. You get the idea. So with that in mind, let us see how do we solve these questions. Now, let's look into them one by one. The very first one looks straightforward, right? However, I've seen students making mistake here. You have to account for discontinuities. This is kind of critical, right? You see there's a discontinuity here, a vertical asymptote. There are two discontinuities. And also notice the hole at the center. Then write the decreasing interval. As such, the function is all throughout in its domain decreasing. Do you see that decreasing? Correct? It is decreasing all throughout. Note one thing, that all the graphs should be seen from left to right. Is that clear? And then write down the intervals. So it is from minus infinity to the first discontinuity, which is at minus 2, and then from minus 2 to the second discontinuity, which is 0, and then from 0 to 2, and then from 2 to infinity. So these are the 4 parts which you have to write. As you can write union or in between. You see that? Either one of them. Correct? So that is the interval. Now, question number 2, as I said earlier, is actually a graph of a derivative. So, where is this function decreasing? If you say from minus infinity to 3, it will be a wrong answer. Do you know why? This is the derivative of the function, not the function itself. So, when is it decreasing? It is decreasing when the derivative is negative, less than 0. And it is less than 0 from in between these 2 points. So it is from 0 to 4. So that is the decreasing interval. You get an idea? So we're talking about this interval when the derivative is negative. That is key to answer the given question. Perfect? So I hope you see how important it is to understand the concept. I hope that helps, right? If you really want to learn from me, you can always send an email on this particular address. I'll be glad to help you. Okay, second, rather third and fourth questions. These are relatively simple. You want increasing interval. So derivative should be positive. Let's find the derivative first. It is minus 6x squared plus 24x, right? Now what is common? Well, minus 6 and x is common. So we get x minus 4. So find the derivatives, critical numbers, right? So critical numbers, so let's say critical number is what? Critical number is x equals to 0 and x equals to 4. Correct? So if you want derivative to be negative, let's analyze the interval. So let's analyze the interval 0 and 4 by taking test points. So let's take test points. From minus infinity to 0, we could take minus 1, 2 here, and let's say 6 on the other side. So the factors are minus 6x, and then the other factor is x minus 4. So minus 6x will be positive when I substitute negative 1, but when I substitute 2 and 6, it becomes negative. As far as x minus 4 is concerned, it is going to be negative for the first 2 values, but positive for the other. And therefore, what do we get? Well, in this case, minus and plus will give me negative, that is positive, and this is negative 2. We are looking for decreasing, increasing, right? Increasing means positive, so that is the interval. So our answer clearly is from 0 to 4. It is increasing, right? Perfect. Similarly, you can differentiate the second function also to get the answer. Denominator will be x squared plus 1 whole square. Numerator 16, derivative is 0, and then minus 16 times derivative of denominator, which is 2x. So we get this derivative as equal to negative 32x, right? So one critical number, and that too at x equals to 0, right? So we can analyze this. At x equals to 0, we have a critical number. Left side take minus 1, right side take plus 1. So if I plug in minus 32x, a negative value, in that case, I get a positive value, right? And if I plug in the, that's my function. So as far as the derivative is concerned, we see it is increasing and then decreasing, correct? Since we want increasing interval, first interval is increasing, which is from minus infinity to 0, right? So it is interval in which it is increasing. You get the idea. So finding derivative helps in this case. Second, next question, question number 5. For what value of k will this function have local maximum at x equals to minus 2? So that really means that the derivative should be 0. That is the first case, right? At minus 2 should be 0. So let's find the derivative first. Okay. So the derivative of this function is what? It is 1 minus k over x squared. Now, derivative should be 0. Let's equate it to 0 and then solve for it. So this implies what? This implies 1 equals to k over x squared, and that gives you the value of k as equal to x squared. Now, we know that, this is for x equals to minus 2, and therefore k is equals to minus 2 squared, which is indeed equal to 4, correct? So we have our answer. Now, how do you confirm that this is a maximum, right? So do that yourself. So for you to do, let me write to do, right? Confirm that k equals to 4 gives maximum, not minimum, right? Maximum at x equals to minus 2. Perfect. This is what you should confirm, just as we did our interval tables earlier. Question 6. Straightforward. Write down the function, find critical numbers, and then do the needful, right? You know, the derivative of this function is what? 6x squared plus 18x plus 12, right? You can factor 6. So it becomes x squared plus 3x plus 4, right? So you could write this as 6 times x plus 4. So now, how do you do this? So 6 is common, right? So you get 6 times 2, not 4. This is 12, right? So 6 times 2. Now, it makes sense. So 2 and 1, right? So x plus 2 times x plus 1. So now you have your critical numbers, and therefore you can easily solve it, right? So we'll make this table, and critical numbers are minus 2 and minus 1. Take test points. As minus 3, you can say minus 1.5, and you can take 0 here, right? So you got 6 is a constant. Anyway, you can write 6 with any number, x plus 2, and then x plus 1, right? Okay. Let's put in minus 1.5. We'll make this as positive only. This is also positive. Now, but here it is going to be negative for minus 2. Minus 3, right? So, in fact, I should write it more towards the left, right? So, let me write these factors as 6, x plus 2 as 1. The other one is x plus 1, correct? So, for minus 3 is negative. As far as x plus 1 is concerned, for minus, these signs will be negative and then positive. Now, the derivative. 2 negatives will give me a positive, negative, and a positive. We are looking for, well, now you can say increasing and decreasing intervals. So now you can write down the answer clearly, right? So those are the, you can say this is local minimum, local maximum, correct? And then answer all the questions, clear? So likewise, you can answer all these questions. Question number 7. Show that this function where a, b, c are non-zero real numbers will not have any local maximum or minimum. Find the derivative, right? So as we discussed earlier, it should not be 0, right? So denominator bx plus c whole square, derivative of ax is a times bx plus c minus ax times derivative of denominator, which is b, right? So this could be written as abx plus ac minus abx over bx plus c whole square. Perfect. And abx cancels. So we have ac over bx plus c, right? Clear? Now, you see denominator is positive, right? So it is product of two constants. Do you see that? And since these two constants are non-zero, so therefore, a, b, c all non-zero, right? So never zero. It is never equal to. So we can write this is not equal to 0, right? No critical number. So therefore, we can answer, justify that it does not have any local maximum minimum, right? Question number 8. Now you're given a function, determine domain, x-intercept, y-intercept, interval of increase and decrease, relative maximum minimum points, right? So these are straightforward questions. I'll also extend to sketch the graph. So these are practice questions. They will prepare you for curve sketching, right? Question number 9, very similar. Another question for curve sketching, right? So sketch curve. So you can include asymptotes, right, in this particular question and then do it, right? Include asymptotes, and if possible, you might have some holes. No, you don't have in this case, but you might check for it. Now here is another. Now these last four questions are very tricky. They're application-based questions. In case you want more than 90% marks, it's kind of must to try them out and master similar questions. So the question here is, the base of a rectangle lies along x-axis and the upper two vertices are on the curve defined by y equals to k square minus x square, where k is a constant. Determine the dimensions of the rectangle with the maximum area. So you need to sketch this and then figure this out. So let's say this is your x-axis and that's your y-axis. Perfect. And this is a parabola, which is, okay, so it's a parabola. So it goes down like this, right? Okay. We have a rectangle which lies along the x-axis. So it lies along the x-axis. Let me make one. Okay, it's not very, let me just do one thing. I'll change this line. It will be better for me, right? Okay. So I'll make it as per my drawing. Now this is better, correct? Right. So that is a parabola, which defined by this equation. We have a rectangle and we need to maximize the area, right? So that's the area. So you can actually check my YouTube channel, check solution from my YouTube channel. I'll provide you links in the comments so that you can look into these videos also and get the solution. However, now you understand how to do it, right? It's a thinking question. Try to do it. Question 11 again. This time, we are given an equation with unknowns. Coefficient of x cubed, x squared, and x is not given to you along with the constant. So f of x is 3x to the power of 4 plus ax cubed plus bx squared plus cx plus d. Find the constants a, b, c, and d if the graph has critical points -2, -73, and 0, -9. So from the critical points, you can easily find the equation, right? 4 unknowns, you need 4 equations. So 2 you will get from the function itself, right? And 2 you will get from the derivative. Derivative equal to 0. You get the idea. Use the given points and then try to do it. Now, once again, in case you want to learn from me, you can always send an email. Of course, you can also see the solutions from my YouTube channel. Similarly, for Question number 12. We have an open top square base storage bin which has a surface area of 108 meters square. Find the dimensions of the bin to have the maximum volume. So make a sketch and then do it. So I will say, let's make a square base. So let's say this is my square base. So 3D figures, try to make them as, as the corner of a room. Look at it, and then that type of figure. It has height. Let us say this is the height, right? So figures help, right? So better to draw the vertical lines together and then join them. Anyway, it does give you an idea of the square base. So basically you are saying square means these dimensions are equal, right? And we can say height is h. Now we know that the surface area is 108. So xh, there are 4 surfaces into 4 plus base x square. That surface area is 108, clear? And the volume will be x square times height. Now I think it should not be difficult. You should be in a position to answer this question. Last question here is with equation where we have a radical function. So radicals are normally difficult. It's good to practice. Now I'll suggest answer these questions. You can always look into my YouTube channel, and if you send me an email, I can actually teach you how to, apply different strategies to answer questions in calculus. So that could be another option for you. Feel free to write comments and share your views on this test paper shared with you. I hope you enjoyed and you like the questions. Try to solve them, and if there's a difficulty, send me an email. Thanks for your time and all the best.